next, shifting gears, let's talk about data at rest. So we've talked about managing the identities. We've talked about the authentication and tokens and cards. Let's look at a data protection risk stack. So when you look at a technology layer, you've got users who log into applications that write to databases that perhaps may be in a Kubernetes or container environment that mount storage. And, you know, of course, that storage can be on-premise, it could be buckets, it could be object storage, it could be anything. But that continues to be the age-old architecture of what technology continues to look at. And when you look at the corresponding as a service, you've got infrastructure, you've got platform and software as a service. And when you look at these and you look at the platform we're able to provide through our CipherTrust manager and the protection solutions you see on the right, there's a number of different layers that you can tackle security. So if it's an application layer, you can use our format preserving encryption. You can make REST API calls to our tokenization service to tokenize data, whether it's for HIPAA, whether it's PII, whatever that may be. And then through applications, of course, that need to anchor keys in a root of trust, we've got our HSMs. And as you go down the line, of course, you've got our transparent encryption with access control. We've got key management. We've got the ability to go through your file servers, databases, big data lakes, and do an object storage and do the discovery and the risk assessment of that data. And then again, as you continue to go down through file volume, all the way down to managing keys for self-encrypting drives and native encryption that many of the storage providers are providing. Now, if you've heard me present in the past, you know that the higher in the stack you implement security, everything downstream automatically consumes that security. So the higher in the stack you're able to apply your security layer, the more stringent and the more secure you are. Now, oftentimes when you look at environments, especially trying to retrofit applications and databases, it can be historically challenging to do so, but we've been accomplishing this with our transparent encryption for many, many years. And not only do we have agency-wide implementations, but also on the commercial side as well. So our CipherTrust data security platform really gives you an end-to-end next-generation platform. It gives you something you invest in that continues to provide ROI to you 6 months, a year, 2 years down the road, because you're centralizing your key management. You're in one environment being able to accommodate for a number of different use cases and different data-centric requirements that you might have. And it starts with the discovery of data. It starts, once you've got that accomplished, then you can not only classify and do risk assessments, then you can figure out which option and where in the application stack you want to apply your encryption. Is it the application layer? Is it through the database? Is it through the file system? And then key management, whether it's bringing your own keys to cloud or whether it's essentially managing keys for break and inspect, or essentially any vendor out there that consumes and generates keys but needs an external key manager. You've got an ability to not only consume keys for what our platform does, but for a number of other services. And a lot, of course, these days use KMIT. So when you look at our data at rest, so it's transparent encryption with access control. And how this works is for a Linux, Unix, Windows system, you install the encryption agent. It's about 20 megs. It takes all of about 8 seconds to install. And what happens when that agent is on that unique system is that now it filters all IO processes to that encrypted data. We don't encrypt the entire volume. We don't encrypt the entire system. We only encrypt the directories that house sensitive data. So if it's a SQL Server, it's a SQL Server database. It's the SQL Server database logs and perhaps another directory for incoming data being scraped in or scraped out. And we lock it down through policy. So data at rest encryption is not enough. Oftentimes, I see self-encrypting drives that constitute data at rest encryption. That's really data turned off encryption, because once that disk spins up, it gets a key from CipherTrust Manager. If you've got root access or local administrative privileges to systems that mount storage, you typically have keys to the kingdom. This ensures that from an insider threat, you are blocking all privileged users to those directories. They can see the contents, the metadata inside those directories, but we're locking down access to a service account, a user that can run a database engine or can run a specific binary. So SQL Server service running the SQL Server database engine has access to data. A local Windows administrator or domain administrator can see the contents, but they can't actually decrypt anything. Now, in the event they will attempt to do something or would attempt to do something, we actually block access. All they see is ciphertext, and we send an alert, that actionable intelligence, to let you know that your data is under attack. You've got an insider threat. And when you look at zero trust architecture and you start and you shrink wrap your perimeter down to the data itself, it's very effective. It's the most effective thing you can do, dollar for dollar, in your cybersecurity spend, is to encrypt your data with access control. This also has the added benefit of protecting yourself from ransomware, from malware, from other things, other processes, rogue binaries that are trying to lock data. Nothing can access that encrypted data, but what you put in the policy. And again, being able to be in a proactive stance to protect your data. So what does this policy-based access control look like? So in this example, you got someone from finance in an AD group trying to look at HR data. And you can see that immediately the policy is going to be triggered, and this person has their access blocked to HR data. And again, that actionable intelligence is written and alerted so that you would know you've either got insider threat, someone's credentials have been compromised, or there's someone else in your environment trying to access something that they shouldn't. Now, if you're an administrator, you should have access to the systems. That's your entire responsibility. So again, you can read the contents of directories, but you're never granted a key. So if you try to grab a transaction log and try to view that, A, you'll only see ciphertext, but B, you will send an alert with timestamp, username, was it a real or an effective user, what specifically was trying to be read, and you can very quickly remediate those type of environments. Now, if you're in need to know, great, it works as advertised. And when you look at the actionable intelligence log, so here's an example from Splunk. These next screenshots are from Splunk. But you can look at different anomalies in different behavior patterns. So here you can see on July 3rd that there are 500 denied access by a user to sensitive data he should not have access to read. And so down below in the lower left, you can see more the granular kind of timestamps, specifically what they tried to look at. And you know that you need to immediately shut down this Tom Taker account and to see if that's a true insider or those credentials have been compromised. But you get this type of information and logistics right from your firewall. You know how many times people have tried to access, try to get through. Well, this shrinks that down to the data itself. So when you look at the overall compliance reporting, again, these are some Splunk dashboard screenshots for our free application there. I always point out on the top right, it's the access attempts from unauthorized agents. That is the gold. So if you're a CISO, if you're an enterprise architect specific to security, and you were to run their support every 30 days, and it came back to say that in the last 30 days, we've had 31 attempts, 26 and 24. Now, maybe it's shadow IT, maybe it's a true threat, maybe it's ransomware, maybe it is an insider threat. But you know that adding up each one of those, and none of those events or those attempts made it through. And you were able to very quickly remediate that situation so that, again, right, from a behavior pattern, but also from remediation, that you're shortening the window of when something is attempting to look at data it shouldn't. You can very quickly resolve that. And when you look at the executive order and data at rest encryption, this is by far, with access control, the most potent way you can protect that data at rest. It's not that it's encrypted, it's that the access control policies and that proactive nature that those agents have can put you in that proactive stance to let you know when your data is under attack. Your data can now defend itself through policy. And again, in the event it's under attack, you can be alerted, take the actionable intelligence, and do something about that. So let's move next into key management. So CipherTrust Manager, most important to you checking boxes is that it's FIPS 140-2, so level 1, 2, and 3. For level 1, of course, being a form factor, being virtual, it's a hardened appliance. It can run on premise, it can run in the cloud. But this is where your centralized key management, your policies, your reporting, everything is built into this CipherTrust Manager, and all these capabilities are built inside of this platform. And there's the ability to do multi-tenancy. There's an ability to do separation of duty amongst your CipherTrust Manager administrators on premise. There's APIs to automate administrative functions. So this is essentially the nervous system of your environment that includes inside of its platform the ability to do encryption, data discovery, app encryption, tokenization, bring your own keys to premise, manage keys through KMIP. So it is truly an ability to centralize your key management strategy going forward. And you look at some of the use cases we support. So of course, I spoke earlier about KMIP, so protocol of exchanging keys, and every storage vendor out there has their own native encryption. A lot of them for self-encrypting drives, and oftentimes have more of a software layer of encryption built in. And we have the ability to manage those keys. If you look at native encryption for Oracle and SQL, we can manage, of course, those keys. We act as an external key manager to essentially make those database environments compliant when you take the keys out of the environment that they're there to protect. We've got the ability to bring your own key to cloud or a multi-cloud approach and create those keys, author those keys, create that key material in a FIPS boundary and provide those to the cloud providers. And then if you've got homegrown apps, right, through PKCS11, again, it is a key management platform that can be used for those aspirations. When you look at root of trust and you look at hardware security modules, our Luna HSMs are not only there to protect traditional, but also emerging technologies. So whether it's dealing with PKI, whether it's to secure digital identities for IoT apps and authentication, integrity of those devices, protect blockchain, protect identities, as we shift into the quantum area, have that quantum agile ability, again, break and inspect and essentially move your own keys to cloud. But an HSM is the safest place on the globe to store your secrets and to store your keys. We have a number of different form factors of our Luna T-Series hardware security module. So we've got a network, we've got a backup, we've got a PCIe card. What's important, again, is these are government purposed hardware security modules. They are performance optimized for government mandated algorithm and key links. The performance, the fastest performing HSM on the market. And again, it ensures that you're checking the box for a FIPS certified key manager and root of trust.